Welcome to this explainer. So, have you ever just stared blankly at a massive spreadsheet and felt completely overwhelmed? Or maybe you've looked at a presentation chart and thought, what on earth is this actually trying to tell me? Well, don't worry, we've all been there. Today, we're going to explore a framework that takes the guesswork out of data visualization and turns it into a real science. We're going to decode the hidden language of data together so you can start building visual stories that actually make sense right off the bat.
Okay, let's dive right into this. Here is our quick roadmap for today. We're kicking things off with the Curiosity Challenge. Then we'll break down the master data taxonomy. After that, we map data to charts, look at a really fun segment called Expectation versus Reality, and finally, put it all to the test in the real world. By the time we wrap up, you're going to have a foolproof framework so you never build a bad chart again.
All right, Section 1, the Curiosity Challenge. Because before we jump into the solutions, we really need to understand the underlying problem. And honestly, the biggest hurdle in data visualization is a trap almost everyone falls into. We tend to treat all data points as if they are exactly the same thing.
So picture this. You just surveyed 100 students. You've got their gender, their age, their height, and their CGPA, their grade point average. I want you to think about this critically for a second. Can you really display all of these variables using the exact same graph? Imagine trying to plot a blood group of A positive right next to an attendance rate of 92% on a single line chart. It's an absolute visual nightmare, right? It sounds totally ridiculous when you just say it out loud.
And that brilliantly illustrates our foundational rule here. Data, purely on its own, is just raw facts. A temperature of 98.6, a student ID, an email address. Sitting alone, they mean pretty much nothing. They only become useful after proper analysis and visualization. But if we try to just force completely different types of data into the wrong visual box, we aren't just confusing people, we're actually actively misleading our audience.
Let's move to Section 2 and see how this builds into our core solution. To prevent all this data chaos, we need to treat data exactly like a detective treats clues at a crime scene by using a rigorous, logical classification system. Welcome to the Master Data Taxonomy.
I want you to think of this blueprint like a prism. Raw, unorganized data comes in, hits the prism, and gets split into two really distinct, beautiful categories right at the top level. Qualitative on the left and quantitative on the right. Literally every single data point you will ever encounter in your career lives somewhere on this family tree. So let's break down those branches.
Okay, first up, a quick refresher on qualitative data, also known as categorical data. This is all about traits and labels. And because they are just categories, standard math simply does not apply here. I mean, you already know you can't add blue eye color to brown eye color and somehow find an average, right? But it's super helpful to remember that even within these categories, we have two distinct flavors. To break this down, just use this simple rule of thumb. Ask yourself, do these categories have a natural sequence? If they don't, it's nominal. Think blood groups, eye colors, or company departments. There's no inherent ranking that makes HR mathematically higher than sales, right? But on the flip side, if a natural order definitely exists, it's ordinal. Think of customer satisfaction surveys ranging from very dissatisfied to very satisfied, or t-shirt sizes from small to large. In those cases, the order absolutely matters.
Now, pivoting over to the number side of our taxonomy, we have quantitative data. This is your numerical data. This is where your standard arithmetic operations finally actually make sense. Here, you can absolutely calculate averages, sums, and standard deviations. But just like categorical data, these numbers play by their own specific rules and subdivisions.
So within quantitative data, we split things into discrete and continuous values. It really just comes down to the difference between counting and measuring. Discrete data is countable stuff, like 100 students in a room or 5 cars in a driveway. Continuous data, though, represents measured values that can be infinitely broken down into smaller fractions, like measuring exactly 175.5 centimeters of height or the precise temperature outside.
All right, now that we've successfully decoded the language of data and explored our taxonomy, it's time for the magic to happen. Section 3, mapping data to charts. Let's translate these classifications into actual visuals. Whenever we map categorical data to charts, the underlying logic has to dictate the visual. Nominal data, those unordered categories we talked about, pairs beautifully with standard bar charts or simple pie charts, assuming you don't have too many categories, of course. But ordinal data, with its built-in sequence, basically demands the structure of an ordered bar chart. The visual flow simply has to match the logical flow of the data.
Okay, I absolutely cannot emphasize this next point enough. This is a golden rule. Avoid drawing lines between disconnected categories. If you put computer science, mechanical engineering, and civil engineering along an axis and then connect them with a line, you are literally implying a trend over time or some continuous relationship where absolutely none exists. It's a massive analytical faux pas. Stick to bars for distinct categories, for sure.
Now, what's really fascinating here is how perfectly tailored our numerical tools are for highly specific jobs. A histogram beautifully shows the distribution of single continuous data. If you want to show the relationship between two different variables, a scatter plot is your absolute best friend. Time series data naturally fits a line chart, and if you're dealing with geography or hierarchies, things like maps and tree maps are going to do all the heavy lifting for you.
So you might be wondering, how do we memorize all of this? Well, you don't have to. Whenever you're building a dashboard or throwing together a presentation, always just ask yourself these 3 sequential questions to narrow down your options. Step 1, is the variable numerical or categorical? Step 2, if it's numerical, is it continuous or discrete? And step 3, if it's categorical, does it have a natural order?
Those 3 simple questions map perfectly onto this chart selection flowchart. Think of this flowchart as essentially your master decoder ring. You just start right at the top, answer the basic yes or no questions about your data type, and follow the arrows. It guarantees you end up at the perfect visual representation every single time. Got ordered categories? Ordered bar chart. Continuous numerical data? Histogram. It literally removes all the guesswork for you.
But what happens when people decide they don't need the decoder ring? Let's move on to Section 4, Expectation versus Reality, and look at the absolute chaos that ensues when folks ignore the taxonomy.
It's super vital to realize that a bad chart isn't just an aesthetic problem. It's not just about looking ugly. Choosing the wrong visualization actively hides key insights and totally misleads decision makers. Honestly, a poorly constructed chart is often worse than having no chart at all, because it creates a false sense of confidence in completely flawed conclusions. I mean, just look at some of these common design disasters. A pie chart squeezed into 20 tiny, unreadable slices, unless it's an actual pizza we're sharing. Nobody wants to look at that. You literally can't extract a single ounce of value from it. And using a line chart to connect HR, IT, and sales? Come on, that implies a trend that just doesn't exist. Plotting blood types on a scatter plot as if A and B have X and Y coordinates? These are absolute visual absurdities. Yet somehow they happen in boardrooms every single day.
Well, we're going to make sure you never make those mistakes. It's time to put all this theory into practice with Section 5, the real-world field test. We are going to look at some actual variables and see how you'd handle them. Check out these 2 raw data sets. On the left, we've got an agriculture data set with variables like crop type, rainfall, and temperature. On the right, a healthcare data set featuring gender, blood pressure, and diagnosis. How would you categorize these using our master taxonomy? Let's process a couple of them together.
When we lay them out in a dashboard blueprint like this, the logic becomes completely undeniable. Crop type has no numerical value and no inherent order, right? So it's nominal. That means we use a bar chart. Temperature is a measurement that can be infinitely precise, so it's continuous, meaning a histogram is going to show its distribution perfectly. Diagnosis is another unordered category, nominal again, so if there are just a handful of common diagnoses, a pie chart or bar chart works flawlessly. By filling out this blueprint, you are proving that matching the data type to the chart is a completely repeatable, highly scientific process.
Before we wrap everything up, take a quick glance at these quiz questions, just to test out your new mental models. If you instantly know that blood group is nominal, or that monthly sales obviously need a line chart for time series, or that height versus weight requires a scatter plot to show a relationship, then congratulations, you have successfully mastered the taxonomy.
And that brings us to the end of our explainer. I want to leave you with this powerful thought as you head back to your spreadsheets and dashboards today. The next time you go to insert a graphic, just pause and ask yourself, is your next pie chart hiding the truth, or is it finally telling a clear, compelling story? Because now you have the exact tools you need to ensure your data speaks the truth every single time. Thanks so much for joining me on this visual journey. Keep experimenting out there, and I'll catch you in the next explainer.